Where shall I begin? UFO. First, remember what the U stands for in UFO. Now, there's a fascinating frailty of the human mind that psychologists know all about, and it's called argument from ignorance. And this is how it goes. You ready? Somebody sees lights flashing in the sky. They've never seen it before. They don't understand what it is. They say, a UFO. The U stands for unidentified. So they say, I don't know what it is. It must be aliens from outer space visiting from another planet. Well, if you don't know what it is, that's where your conversation should stop. You don't then say, it must be anything. Okay? That's what argument from ignorance is. It's common. I'm not blaming anybody. Psychologists know all about it, and it may relate to our burning need to have to know stuff because we're uncomfortable, steeped in ignorance. You can't be a scientist if you're uncomfortable with ignorance, because we live at the boundary between what is known and unknown in the universe. Unlike what journalists write. You ever see journalists? Any journalists? You know, a journalist. You know, a journalist. All articles about science discoveries begin. Scientists now have to go back to the drawing board, as though we're sitting up in our office, you know, masters of the universe. It's like, oops, somebody discovered something. No, we're always at the drawing board. If you're not at the drawing board, you're not making discoveries. You're something else. So, the public, it appears, seems to have this burning need to have an answer to what is unknown. And so you go from an abject statement of ignorance to an abject statement of certainty. So, that is operating within us. Let's start there. Second, we know, not only from research in psychology, but simple empirical evidence in the history of science, that the lowest form of evidence that exists in this world is eyewitness testimony. Which is scary because that's some of the highest form of evidence in the court of law. But we know from second grade. Where's my guy from second grade? Hey, get up to the microphone for a minute. Grab the microphone. Grab the microphone. In your classes, have you done the famous experiment where you play telephone and you line up all your kids in class and one person starts with a story and then you hear it and you repeat it to the next person and the next person? Have you done that in class yet?
Yes.
You've done that experiment? Because what happens by the time you get to the last person and they retell the story? What happens?
It's like completely different.
It's completely different! Completely different, okay? Because the conveyance of information was relying on eyewitness testimony, which in that case is ear witness testimony. And so, let's thank you. So we know that. So he knows it. He's in second grade. All right. So, actually he should be in 12th grade as we've established. So now, it wouldn't matter if you saw a flying saucer. In science, even if you have something less controversial than a flying saucer, if you come into my lab and you say, you gotta believe me, I saw it, and you're one of my fellow scientists, I say, go back, go home. Go back until you have some other kind of evidence that's not just you saw it. Okay? Because human perception system is rife with all ways of getting it wrong. Okay? But we don't like thinking of ourselves that way. We have high opinions of our human biology when in fact we should not. I'll give you an example of how it reveals itself. We've all bought and enjoyed books called optical illusions, right? Well, we all love optical illusions, but that's not what they should call the book. They should call them brain failures, okay? Because that's what it is. It's a complete failure of human perception, all right? All it takes is a few sketches that are cleverly done. Your brain can't figure it out.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Ah, the seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. And the reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth. And there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're in the part of the Earth that's toward the sun...
The Earth is a closed system. We cannot leave the Earth. There's no place to go.
Now, one thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth. There's no place to go.
The technologies that we're testing out on Space Station are definitely helping us with our goals of going beyond low Earth orbit. So we have a really robust exploration program at NASA.
Previous program, we are setting a course with specific and achievable milestones. Early in the next decade, a set of crewed flights will test and prove the systems required for exploration beyond low Earth orbit.
The oxygen it's the main crucible test bed where we've been trying to grind out all the lessons that will eventually let us go to the moon, that will eventually let us go to the moon.
Astronauts to the moon.
Well, I think it looks so ridiculous and impossible. And you can tell it's real because it looks so fake, honestly. We'd have way better CGI if it was fake. And you know, the colors all look like kind of weird in space. There's no atmospheric occlusion. Like everything's too crisp. But we didn't really test any of those materials for, is it space hardened or whatever. So it just has the same seats that